This is our project on predictive analytics for the Titanic ML competition utilizing Knime on Kaggle. Our group is Function Junction with Drew Nally, Duncan McAleese, Ali Scheimer, and Morgan Malillo. This is for MGSC 394 with Dr. Sungi Park and was recorded on November 24th, 2024.
As for our executive summary, the Kaggle Titanic competition tasks our group with predicting passenger survival using features like age, gender, and class, utilizing separate train data for modeling training and test data for evaluation. Our group exercised the full data science workflow, including data cleaning, feature engineering, model development, and testing predictions on unseen data to produce the most accurate result that we could identify. The challenge emphasizes understanding feature importance, comparing models, and learning through collaboration and shared insights. We have learned that success in machine learning heavily depends on thoughtful feature engineering and effectively handling missing or incomplete data, not just choice of algorithms. Our key features like age and family can be significant to improve predictions. Our group utilized this to ensure effective outcomes. Incorporating the train data first helped our group to avoid overfitting to the test data. Training data by ensuring that pre processing steps generalize well to unseen test data, and the competition highlights that understanding the data set, cleaning it, and extracting meaningful patterns are foundational skills in data science, often outweighing the performance differences between complex models. As for our business understanding, the Titanic dataset is a popular introductory challenge for learning predictive analytics and machine learning. The objective of this project is to use historical passenger data from the Titanic tragedy to develop a predictive model that determines whether a passenger survived or perished. The dataset includes features such as age, gender, class, fare, and family connections, all of which could have influenced survival likelihood. Our project plan is to first understand the Titanic data we're working with to effectively prepare the data so that it can be modeled in a way that produces the highest predictive accuracy.
Before we prepare the data, it is important to fully understand the data, including the fields and columns. We divvied up the columns into what we deemed important and relevant. The age column includes the age for each passenger. Younger passengers might have been given priority in rescue efforts, and age-related vulnerability affects survival chances. SIB-SP refers to the number of siblings and spouses a passenger had aboard. This metric indicates group dynamics which could influence survival strategies. Parts represents the number of parents and children a passenger had with them on the Titanic. Family presence could impact survival rates because families often stayed together during evacuation. The fare represents the ticket price paid by the passenger for the journey. This serves as an indicator for socioeconomic status, with higher fares generally correlated to first-class accommodations. Passengers in first class often had better access to lifeboats, which could significantly impact survival rates. The prediction column is whether a passenger is predicted to survive. This is obviously the key outcome to the challenge. The remaining columns we deemed less relevant. Passenger ID is the identifier for each passenger. This doesn't provide any further analysis and isn't relevant on their chances of survival. Name can be used to show relationships with other passengers. However, SIG-SP and PARCH can show this better as they show direct relationships and not just names. Ticket is just their ticket number, and this is basically useless because it does not show anything about the passenger or their survival chances. Cabin could show proximity to lifeboats, but the data is hard to understand and most of the data is missing. Embarked identifies the port where the passenger boarded, which could show regional demographics, but is tricky to correlate to survival chances.
When preparing the data, we followed 5 steps. The first thing we did was uploaded the test CSV and the train CSV sources into Knime using the CSV reader nodes. After that, we started adding nodes. We first added the missing value in the number string to both of the tracks, and then added the partitioning random forest learner, random forest predictor, and score onto the track specifically. Then we added the node CSV writer to random forest predictor, and then connected number to string to it. We then configured each node's settings along the way, then began feature engineering as we will outline in the next model building steps.
The selection of our initial model was with the intent of utilizing nodes to clean up the existing data and have a random sample be generated. The missing value node was used to set the missing data on some of the passengers' ages to be defaulted to the median for that data set. The number to string node was used to turn select fields into the string type. The partitioning node was used to split the first partition into a 90% split. Then, the random forest learner trained the model using these adjustments, and the random forest predictor applied the model to create predictions. We used the scorer node to see our accuracy, then the CSV writer to export the file and upload it to Kaggle, where we got our first score of 75.3%. In the second model, we added a rule engine to create age classifications for each age range. This was done by adding a rule engine where the age ranges were labeled for infant, child, teenager, adult, and senior. This was to provide better accuracy on how the passengers would have been treated in the moment, because amidst all that chaos, they would not have noticed the difference between a 14 and 15-year-old, hence why they should be grouped together, yet they would notice the difference between a 16 and 26-year-old, for example. This provided a slight upgrade to 76.7%. In the third model, we added a string manipulation to recognize the first four characters of each passenger's title. This was an effort to use the passenger's title to predict which age group the passenger likely was. So, we used the rule engine to sort Mrs., Mr., and Doctor into the adult category and Miss and Master, for master, into the child category. This was able to raise our score another 1% to 77.8%.
We believe that the user can use this in 5 simple steps. The first step is going to be to launch Knime and open our provided Titanic prediction workflow and ensure that everything loads in correctly. Then we're going to load the input files by double clicking on the input nodes, which are the train CSV and text CSV, browse to files, and then confirm. Then you will click the green run button to execute all nodes and generate predictions. Make sure to check the predictions in the output node labeled predictions and verify the survival outcomes. Lastly, we will execute the CSV writer node to save predictions and then upload the file to Kaggle for evaluation.
Lastly, the deployment regards the challenges that we have faced, how user-friendly and widely applicable our model is, and the success that we've created from it. Our group faced many challenges when it came to deploying the model, especially when it came to cleaning the raw data set, which had numerous missing values. We also worked to identify patterns between certain variables and the survival rate. While there may have been a clear influence between many of these features, we had to work to provide quantified variables for all of them. This data was an eye-opening real-world example of what complexities data analysts may come across. The prediction model we built can be applied to many real-world examples by simply changing the variables and adjusting the data set. Different industries can utilize this model by connecting their own historical data. Overall, this project has been an amazing opportunity to solve real-world problems that data scientists may face and also understand the power of predictive modeling. This model is something that many different companies can utilize. It is user-friendly while performing complex calculations and making them simple and efficient. It will prove valuable to different industries while performing predictive tasks, and the future of data analytics lies within companies transferring their data over to models similar to this.
Thank you for listening to our presentation.